Welcome to the fifth video of the module 3. In this video, I am going to explain the derivation of the wave equation. So, derivation of one-dimensional wave equation. Let us consider a flexible string tightly stretched between the two fixed points at a distance L apart and P be the mass per unit length of the string. We will assume some conditions, that is, tension of the string is same throughout. Effect of gravity can be ignored due to large tension, and motion of the string is in small transverse vibrations. This is the diagram. So we consider the force acting on small element AB of length delta x and T1, T2 be the tensions at the point A and B. Since there is no motion in the horizontal direction, the horizontal components T1 and T2 must cancel each other. Therefore, T1 cos alpha is T2 cos beta is equal to T. Let us call this as equation number 1, where alpha beta are the angles made by T1 and T2 with the horizontal and vertical components of the tension are minus T1 sin alpha and T2 sin beta, where the negative sign is used because T1 is directed downwards. Hence, the resultant force acting vertically upwards is T2 sin beta minus T1 sin alpha. Applying the Newton's law of second law of motion, force equal to m into A, we get T2 sin beta minus T1 sin alpha is equal to rho delta x into dou square u by dou t square. Psi delta x is the mass of the element portion AB, and second derivative with respect to t represents the acceleration. Dividing throughout by t, we get T2 by t sin beta is equal to minus T1 by t sin alpha is equal to rho by t delta x into dou square u by dou t square. But from 1, T1 by T2 is equal to 1 by cos alpha, T2 by t is equal to 1 by cos beta. Therefore, sin beta by cos beta minus sin alpha by cos alpha is equal to rho by t into delta x dou square u by dou t square. That is, tan beta minus tan alpha is equal to rho by t into delta x dou square u by dou t square. But tan beta and tan alpha represent the slopes of at b of x plus delta x and a of x respectively. Therefore, tan beta is dou u by dou x and tan alpha is dou u by dou x at x. Now the second equation becomes dou u by dou x minus dou u by dou x at x is equal to rho by t into delta x into dou square u by dou t square. Dividing by delta x and taking the limit as delta x tends to 0, we get limit as delta x tends to 0 of dou u by dou x into x of x plus delta x minus dou u by dou x of x divided by delta x, which gives us rho by t into dou square u by dou t square. But the LHS is nothing but the derivative of dou u by dou x with respect to x treating t as a constant. That is dou by dou x of dou u by dou x or dou square u by dou x square. Hence, we have dou square u by dou x square is equal to rho by t into dou square u by dou t square, or dou square u by dou t square is equal to t by rho into dou square u by dou x square. Denoting t by rho with a c square, we get dou square u by dou t square is equal to c square into dou square u by dou x square, or utt is equal to c square uxx. This is the wave equation in one dimension. Thank you.